What if I told you that I have the results of your Chapter 1 quiz, and that your class did okay compared to others, but you did especially well? You might be asking and patting yourself on the back for one thing, but you also might be asking certain questions like, well, how did our class do compared to others? Exactly. And what was the average? Like, how much better did I do? What was the lowest score? What was the highest score? These are all questions that are actually typical questions in psychology when you're gathering data. So what we want to do here is we want to talk about psychological data and how you present it. And so, organizing, presenting your psychological data. Now that you've gone out there and you've messed with people scientifically, you've gathered the data, it's just a bunch of numbers now. You got to do something with it. So you have to organize it in some way, because you're going to publish this in some journal, So statistics and data is important topic here. There's three main questions about psychological data that you want to ask. Three main questions about that quiz, the results, the data from the quiz that you'd want to ask. Number one, what's normal? Like, that's what's typical. What's normal behavior? What's normal thought? What's the average score? What's a typical result on the quiz? So that's where you get average and such. And what is normal is a huge question we ask in psychology. So definitely there's a lot of data and statistics that will express what is typical, what is normal. We'll also want to know, the second question might be, how much deviance is there, like away from the norm? What was the highest score? I did well on the quiz, but who did the highest on the quiz? Or who got the lowest score? Like, how much deviance is there, or variety? So what is normal, what is typical, but also what is deviant, and how much variety is it? Or did everybody just hover around the average, whatever the average was? Did some a little higher, some a little lower? Or was in some classes, like somebody got like a 10 and someone got a 20 and somebody got 100, in which case there's a lot of deviance or deviation or variety in the scores. So that's variability or deviation. So what is normal? How much variability or variety is there? And the third question, typical of psychological data, is this and that related somehow? And how are they related? So correlation, what might be a correlational question we would ask? Well, of those who did score higher, what did they do? Like, is there a correlation with how many hours they put into the reading? Is there a correlation in how many notes they took on the outline for Chapter 1? Or certain classes, are there correlations with some classes doing better than others? So what is normal, typical, average, mean? How much variety or variability or deviation away from what is normal is there in people's behavior or quiz scores? And thirdly, is this and that correlated somehow? Are they positively correlated, where they move in the same direction? When one goes up, the other one goes up. One goes down, the other one goes down. So are they correlated that way? Or are they negatively or inversely correlated, where one thing is higher, the other thing drops? Whereas this one goes lower, the other one goes up. And that's negative or inverse correlation. So let's look at the first question, which is, there's the three questions we were just talking about. So let's go to what is normal. And this is in statistics called measures of central tendency. That's just a fancy way of saying what is typical, what is normal in people's behaviors or whatever. And there's three measures of what is normal or typical or the central tendency, and that is mean, median, and mode. And you've probably heard of these before. The one very often used is the mean, the mathematical average. So in the case of the quiz scores, we're basically taking all 30 of you and your scores, and we're dividing by 30 to come up with the average. And that's great, but this is important. there are some situations where mean is not the best way to express what is normal. It actually could deceive people. And sometimes people throw around statistics and say averages or mean, and it actually is not expressing what is typical. So median and mode are important. Median, of course, is where you line up the scores from top to bottom and you pick the middle one to express what's typical. Whereas mode is you look at the most frequently occurring scores. So if a lot of people are like 75, 75, 75, 75, and that is the most frequently occurring score, then 75 would be the central tendency, or what is typical of third periods quiz scores or whatever. These are important because freak scores, extreme outlier scores, that might throw off your understanding if you're using mean. In other words, if you're using mean, and there's a particular class that has a lot of people who are planning to drop the class, so they pretty much didn't even do the quiz, or just put random answers down, and so they all got zeros in that particular class. Those extreme low scores is going to pull that class's average down, and you read that and you look at it and you think, oh my gosh, this class is doing horrible. But that's because of their extreme low scores that got factored in. If you're looking at income, that's sometimes an issue too. In certain cities, there's extremely wealthy people that might happen to live there, and their extremely high incomes of bazillions of dollars would pull that average up and misrepresent what is typical in terms of income of people living in that particular city. So yeah, those are measures of central tendency. Let's kind of skip that for now. How much variability or variety or deviation away from the average is there is our second question we were talking about. And so here we have the bell curve. When we're talking about variability, variety in the scores, you've got what's typical here, the hump, is typical. And then over here you got the extreme scores, extremely high or extremely low. Bell curve is great for a lot of things. Bell curves psychologists love using because it shows kind of a representation of the population on all kinds of stuff. You could use a bell curve to represent IQ. You could use a bell curve to represent shoe size or the typical weight, average weight of people, or height, like all kinds of traits among the population could be represented here, where what's most normal is here and what's like really deviating, and extremely low here or extremely high here. This is important that we understand what standard deviation is. Standard deviation is kind of a favorite question on the AP exam, so we want to make sure we understand it. So let me try to clarify what this is. Standard deviation is a statistical formula that calculates a pattern of deviation above the average and a pattern of deviation below the average on a bell curve. So let me say that again. Standard deviation is this formula that calculates a pattern of scores moving this way and a pattern of scores moving down this way. So first you have to figure out what the average is, and then you plug in this formula. Now you can look this formula up in your book if you like. It's kind of lengthy, and those of you taking AP statistics may need to know it anyway. For us, we're going to cheat a little bit and take a shortcut. Whenever you use standard deviation, you plug in the formula, whether it's shoe size, height, weight, IQ, SAT scores, which is, I think this one might be, it's always the same percentages on the bell curve, no matter what trait you're representing on the bell curve. When you plug in this formula, it's always, you see these percentages are all the same. In this case, you guys, this here across the bottom, the average is 100, and then it goes up every 15 points. This is IQ being represented here. As we'll learn later this semester, IQ, the average IQ is 100, and then there's patterns that move this way and that way. When you plug in the standard deviation formula, it turns out that every 15 IQ points is a standard deviation. Every 15 points, because that's 34% this way and 34% this way and 14 and so on. This right here is like one of the parts of the SAT that goes up to 800, let's say the language portion of the SAT, where the average is 500, I guess, and then it goes up to 800. Again, when you plug in the standard deviation formula, then you figure out the average at 34% this way and so on, it's going to come to every 100 SAT points this way, every 100 SAT points this way. So let me ask you this question. Based on these bell curves here, what percent of a population would fall between -1 and +1 standard deviation? So what percent of a population on any bell curve, whether it's height, weight, IQ, SAT, whatever, what percent of the population will fall within 1 standard deviation to each side of the average? 68. In other words, 34 plus 34. Everything in yellow here. Between here and here, that's 68% of the population. So a little over half, about 2/3 of the population will fall between this and this. And that, in terms of IQ, happens to be 15 points below the average and 15 points above the average. 68% will fall within the yellow area. That's 1 standard deviation. Next question, what percent of the population will fall within 2 standard deviations above and below the average? And if you're doing your math there, 14 plus 34 plus 34 plus 14, in other words, from here all the way up to here, that's going to be about 96% of the population. So vastly most people will fall between -2 and +2 standard deviations. Vastly most people in the population. And then, of course, we go even further. What percent falls within 3 standard deviations, from way up here all the way to down here? And that's like 99%, definitely most. One thing I'll say in terms of IQ, which we'll learn later, it turns out that 2 standard deviations below is IQ of 70, and 2 standard deviations above is an IQ of 130. That actually is used to demark intellectual disability. So IQ of 70 and below is considered intellectually disabled, and this is considered giftedness, which is 130 and above. So we'll get into that later this semester. So that is standard deviation, this statistical formula that calculates a pattern of variation above and below the average. It's always the same percentages, though. All right, so moving on to the last question. The third question is this and that related? In other words, correlation, they call it. The third question, we were discussing is correlation. So correlation is not causation. That's the first thing we want to say. It's a law in statistics. Just because 2 things are correlated and they seem related doesn't mean one is causing the other. Now, if you recall, one of the advantages of experiment, as opposed to surveys and case studies and such, experiments do get a closer understanding of causation, not merely correlation. But don't get the 2 confused. Correlation is important and informative, but it doesn't mean that one is directly causing the other. For example, just to give you an idea of what we're talking about, did you know that, swear this is true, that ice cream consumption in the United States is positively correlated with violent crime in the United States? Look it up. It's true. In other words, they're positively correlated. So when ice cream sales increase and people are eating more ice cream, you can find with other crime data that violent crimes also increase, and then vice versa. When ice cream sales drop, violent crime drops. So they're positively correlated. They move in the same direction. So can we say that eating ice cream causes violent behavior among the population? No. There's other factors maybe you're thinking of, like people eat more ice cream when it's hot and in the summer, and also there's other things like in the heat people get more irritated and there tends to be more aggressive behavior in the heat. And here's the real factor, teenagers are more available in the summer because they're not in school, so teenagers are out there eating ice cream and going around like beating people up and stuff. So and by the way, you are the most violent age group in the statistics too. So be nice and maybe eat less ice cream. So yeah, So eating ice cream doesn't cause violence, but it is correlated. And there's other things too, like smoking, heart disease, stress, and sleep. There's all these other factors that we could say, oh, these seem to have a connection. They're correlated, either positively or negatively correlated, inversely. But it doesn't mean that one's directly causing the other. So, for example, let's take a look at our stuff here. This is, let's see, hours of students watch TV per week. Let's say it's on this side, the y-axis, and then the GPA of the students. And you end up being a dot on what's called a scatter plot. So wherever this crosses this, each of you is like a dot on there, let's say. The more you watch TV, the more you're binging on Netflix, and probably you're going to find that you have a lower GPA. Now, there's some of you that may not be the case. There's exceptions, but the general pattern is this way. In other words, is this positive or negatively correlated? This would be negative or inversely correlated. As one goes up, the other tends to drop. So that's the angle on a scatter plot of negative correlation. By the way, scatter plot diagrams are really great for showing correlation. That's one of the favorite graphs for showing correlational results. GPA of students and SAT scores. Well, this is showing positive correlation, which moves this way on a scatter plot. As your GPA is higher of students, you find the statistical tendency is that their SAT scores or ACT scores are higher. So they tend to move up this way. And by the way, this is pretty much the kind of graph that the college admissions boards will look at when you're applying to college. When you're applying, you send them your ACT or SAT scores, and your GPA is sent, and you're a dot on their graph along with hundreds of others who are applying to that college too. And hopefully you're up at this end. Now, of course, there's exceptions. Some people do really well on SAT and not so high on their GPA, but the pattern moves this way. If they found that, hey, SAT is perfectly correlated with GPA, it'd be like doot, 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 a dotted line just going straight up. But of course, we all know that some people have low GPA scores and really high SATs and vice versa. That's not perfect correlation. Now, one last thing. When we're talking about relationships of this or that between smoking and heart disease, ice cream and beating people up, or GPA and SAT scores, correlation coefficient is a formula they use to measure just how strong is the link between the two variables. Just how strong is the link between smoking and heart disease, or GPA and SAT score? Well, that's measured with correlation coefficient. Correlation coefficient is measured on a scale of -1 to +1. So when you're trying to measure how strongly linked two variables are, or loosely linked, you use correlation coefficient, and it's on a scale of -1 up to +1. Now, what's between -1 and +1? 0. If the result of the correlation coefficient formula comes out to be 0 between smoking and heart disease or whatever, that would indicate there's no relationship, 0 correlation, which means there's no correlation. One behavior goes up and nothing happens, the other one doesn't respond. So there doesn't seem to be a correlation. On the other hand, is the closer the result it is to +1, that shows a strong positive correlation. It's going to look more like this graph here. The closer it is to +1. The closer the result of correlation coefficient score is to -1, it's going to look more like this. Now, by the way, it never is outside of that range. It's never beyond -1 or beyond +1. It's always within, from -1 up to +1, with 0 in the middle. So the stronger the correlation, stronger the positive correlation, the closer it will be to +1. The stronger the negative correlation, the closer it will be to -1, but never outside of that range. Okay, so that's going to be it for our topic of today, of psychological data and statistics. Fun stuff, eh? I mean, it's, for some of you who are real math-minded and statistics, this is right up your alley, I guess. In any case, it is important that people don't misrepresent what's normal or typical by using statistics in the wrong way. So data, the way you present it can sometimes misrepresent reality. of things, and politicians are good at misusing that sometimes, and media as well. So that is it for today. I just want to remind you, I'm going to go ahead and post it now. The last part of any PowerPoints we show or videos will often have a review section, and there's usually a key that goes with it, and there is a key to this. So see if you can answer these 7 here based on what you've just learned. And pause the video for a moment, and I'll go ahead and show you the key. So pause it so you can work through those, and here is the answers. There you go. So see how you did on that. All right, and that is psychological data and statistics.